Okay, here we are talking complex fractions on a beautiful Tuesday. If you have a fraction divided by another fraction, that's your old friend keep, change, flip. You keep the numerator the same, you change the division to multiplication, and you flip the denominator. Because division is the same thing as multiplying by the reciprocal. And then you do your math like normal. You could reduce, and I end up getting 4/3 as that answer, right? So if you have a fraction over a fraction, easy enough. If we're looking at this worksheet though, I have a fraction over a subtraction expression here. So it's not quite keep, change, flip yet. So step one, what I need to do is I need to create a single fraction over a single fraction, which means I actually need to subtract these two and get an answer. And then once I have one fraction over another fraction, I can do keep, change, flip. Okay? Ready? So I'm actually going to ignore the numerator altogether just for a minute. And I just want to do 9/4 minus 25/12. So of course to subtract fractions I need common denominator. So I'll multiply the first thing by 3/3. So I'm really doing 27/12 minus 25/12. So I actually get I get 2/12, which is the same thing as 1/6. Should you, oh, not 1/16. Should you reduce it? Absolutely. If you don't reduce it now, you're going to have to do it later, and your numbers will get bigger. So anytime you can reduce, go ahead. All right, so let's do keep, change, flip. I'm going to keep the numerator as it is, 25. I'm going to change the division to multiplication, and then I'm going to take the reciprocal of my denominator, which is 6. So it's really just 25 times 6, and my final answer is? What is it? 150. So that's really it. Just get your comments, get a single fraction over a single fraction, yeah.
So like in question 2, does the common denominator at the top all have to be the same as the bottom?
No, great question. So she asked, do all three of these have to have a common denominator? No, they don't. I'm actually gonna, you really just do one piece at a time. So let's just look at the numerator. Let's just get those two subtracted. 36 in this case, so I'd multiply by 9/9. So it's gonna be 27 over 36. Oh, and I'm gonna do 4/4 over here. And there'll be minus 100 over 36. So 27 minus 100 is a negative 73. So that's my numerator. Negative 73 over 36. So keep my numerator as it is. Change to multiplication. And then let's flip this denominator over. 25/2. If there's anything that I could reduce here, you can. Anything on top can reduce with anything on the bottom, but what can I do? Can I do anything? I don't think you can. Which is nice to check now, because if you can't reduce anything here, then your final answer can't be reduced either. So you don't have to recheck it. Sure. Anybody see anything that I'm missing? So, we'll just take out our handy dandy calculator. I don't know, I was just trusting you. But I'll check it. Yes, you did. And 36 times 2 will give me a 72. Whoop. So that's it. So let's jump to one that's harder that has some letters in it.
What about one on the back? Like,
Okay.
number 8?
All right, 8.
That one seems scary. But wait, what was the answer for the last one?
Yep. You don't ever have to worry about changing it to a mixed number. Who cares? It just has to be reduced. All right, so 8 we are on. All right, so the numerator is already a single fraction, so that's I don't have to worry about that. I just have to worry about my denominator. What will the common denominator be for these two? U squared, right? So this one just needs to be multiplied by u over u. So now I'm going to have u over u squared plus u plus 6 over u squared. So I actually get, you're just adding, right? So just 2u plus 6 all over u squared. That's my denominator, right? So now I just do keep change flip. So u plus 6 over 36, keep the numerator, change the multiplication, flip the denominator over, u squared over 2u plus 6. All right, now this really becomes a problem like we did last week, right? To see if I could simplify this. So remember what the steps are now. You factor everybody, cancel out whatever you can, and then write your final answer. U can't be factored, you can't. I could take a 2 out of u, and then I'm left with u plus 3. Is there anything that I could cancel or reduce, or anything that I can do? No. So, pretty much done. I just need to multiply straight across. Do you need to FOIL all this out? No, I mean, if it's multiple choice and they've multiplied it out, then go ahead and multiply it out. If it's a normal test that you get to write in your own answer, and you write it like this, that's fine. It's not a big deal. I can do 36 times 2, so I should do that. 72 u plus 3. So there would be a final answer. So again, if it's multiple choice and you don't see it written like that, then they probably just multiplied it through. Which way are they going to do it? I don't know. It would depend on what the software is programmed to do. Of course. Ooh, 9's a great question because now we have 2 fractions on top and on bottom. Oh. Huh? Can you wait till Tyler comes back? Thanks. So, just focus on one set of fractions at a time. So if I look at the numerator, what would my common denominator be? 6. So let's multiply this side by 2 over 2. So that's 5, 6 plus 4, 6 really gets me 9, 6. Or, huh? Oh yeah, I'm not there yet. 9, 6, I can reduce that 3 halves. Right? Everybody agree? Am I going too fast? I'll slow down. There's my numerator. Now I'll look at the denominator and figure that out. What's? Yes, my common denominator in the denominator is 25x squared. So, this guy needs to be multiplied by 25 over 25, and you need x squared over x squared. You have to do it. Good thing you have 900. Wow. So that's 900 over 25x squared minus 6x squared over 25x squared. So that does become, let's see, 900 minus 6x squared all over 25x squared. Okay, you with me so far? So there is my denominator combined into a single fraction. So now I can go ahead and multiply by the reciprocal. And now it's a multiplication problem. So let's see, nothing to factor. There is something to factor here. I could take out a bigger. I can take out a 6. In fact, I'm going to take out a negative 6. Well, maybe not. All right, let's just take out a 6. Can I do anything? Yes, 3 and 6 can be simplified now. Anything else? Well, if that were the difference of two perfect squares, I could, which is why I was thinking I'd take out a -6, but it wouldn't matter anyway. Yeah, 1/50 is not a perfect square, so I'm kind of stuck. So, can I go any further? No. So, I'm going to have 25x squared as my numerator, and then 4 times 150 minus x squared as my denominator.
When we do the evens,
Um,
or just the odds.
well,
Instead of like do the evens.
do you want to do any more together, or are you guys
Can we do both real quick?
7? We can do 7. So, numerator is already a single fraction. Denominator, not that far off, because all I have to do to get common denominators is, yes, multiply u by 2 over 2. Please be careful, though. When you multiply this by 2, you're multiplying all that by 2. So it's really 6x minus 2 over 4. And be careful, this is subtraction, and you have to subtract all that. So you're really going to be doing, you're going to have 6x minus 2 minus 3x plus 1 all over 4. Right? Because you have to distribute that negative to both of those pieces. So when I finally simplify this denominator, it looks like I get 3x minus 1 all over 4. And now I can do keep, change, flip. Keep the numerator, change the multiplication, flip the denominator. And then I get to,
Cancel.
yes, cancel those 4s, and I'm done. X over 3x minus 1. Bingo bango. They're kind of fun, aren't they? You see? Psh. It's like that dish that looks really gross, but then someone convinces you to try it, and then you're like, oh, it's actually really good. See? Same thing.
Are you